For the next example, we are given that most infants start to walk when they are approximately a year old. Most horses are able to run within a few hours after birth. The fact that horses mature much more quickly than humans makes it difficult to estimate the age of a horse in human years during the horse's first year. However, the following function models the age in human years of a horse that is X years old. So X represents the horse's age, H represents the human's age. In human years, it wants us to estimate the age of a 16-year-old horse. In that case, we are given the X value. So right here, we are given the X value. In part B, it says to estimate the age of a horse whose age in human years is 32. In this case, we are given the Y value or the H value. So for this, we're going to need to use the graphing function on our graphing calculators. So back to the graphing calculator we are, and we're going now to input our function. First things first, remember, our leading coefficient is negative 2.18. So once again, when you are inputting a negative, use the negative button, which is next to the enter key, not subtraction. So it's negative 2.18 plus 19.27. And again, we don't need to use multiplication here. It's implied ln of x. So again, multiplication is implied between the 19.27 and the ln x. It's implied, so you do not need to put the multiplication there. So now that we have entered this into our calculator, we need to get to our graph. Well, the default graph, if we go to the graph, probably isn't going to show us enough. Remember, it's already asking us the age in human years of a 16-year-old horse. And we are only going up to 10 in the default. So let's go to our window settings and play around a bit. We know we don't need negative years. And let's go to 30 in horse years. Again, we don't need negative age for humans. And let's just go to 100 because it looked like the graph was increasing by a lot there. I'm going to use a scale of 10. So I'm only changing the scale on the y-axis. The x-axis is still going to be a scale of 1. Actually, I can even use a scale of 5 on the x-axis. So now when we graph it, we see a clearer picture of our function. Well, the first one was saying, estimate the age in human years of a 16-year-old horse. So along the x-axis, we know 16, if it's the scale I chose was 5, 10, 15, 16 is somewhere around here, right? And then we could go across. But remember, even with the graph, if we're given an x value, we can use the graph to help us find the result. We simply go second, trace, and we have an x value, so we hit enter, and the number was 16. Remember, this only works when you're given an x value. You can only use that function that we just used when given an x value. So the estimated human years when compared to a 16-year-old horse in human years, that is going to be equivalent to 51.2477 and so on and so on and so on. It keeps going on. So that is when you're given an x value. Remember, in this case, we were given an h value. The h value is also known as a y value in this case. So in order to understand that, If we know that the human, which is our y value, if we know that the human is 32 and we're not given an x value, then we have to go back to y equals and graph the line y equals 32. That will graph a red line going across that intersects our graph. Given that our x values are going up by 10, 10, 20, 30, 32, that's a reasonable place. So now all we need to do to find the solution to this is find that point of intersection. Once again, it's second, calculate, and we need to find the intersection point. And you remember, there's only two functions to select. So all we need to do is hit enter 3 times. 1, 2, 3. And we find that point of intersection. So a 32-year-old horse will, in human years, be 5.893 years. So let's go back to our page and record our results. So we can conclude, based on the results we found on the graph, that the age of a 16-year-old horse is equivalent to 51 human years. And the second part, where we're given the h value, we're now going to be able to conclude that the age of a horse whose age in human years is 32 is equivalent to 6 human years. Again, our results are rounded to the nearest whole year for these problems.